Okay. Okay, and the recording is in progress. Wonderful. So thank you so much. Thank you so much for the invitation. Really appreciate the opportunity. It's great to be here with you online. So hopefully, I'm very looking forward to see you in person. But anyway, today I want to talk about models and simulations, more broadly speaking, what I call computational technologies, and how they are actually shaping the governance of river basin. So these are tools that we heavily rely on to understand the basin, the reality of the basin, if you like. And they are informing our choices about what we want to change, we want to keep. So they are quite fundamental. And as Matty said, I am actually trained as a water engineer, and I know that many people like myself approaching tools as things that are inherently neutral, just there to help us analyze the system. They're quite external to what's happening in the basin, so they're there to help us to analyze the situation. What I want to argue today is that they are actually not outside there, they're kind of like inside there, and they are part and parcel of how things evolve in a basin. So that's kind of my argument today. And so for my talk, I thought maybe I will structure my talk in two sections. First is that I talk about a little bit of a theoretical underpinning of what I want to explain here, why we need to take models seriously, especially in the context of socio-ecological systems, and how we can actually do that. And I will walk you through the case that I'm quite familiar with. Actually, I did modeling when, yeah, do you have a question, Brent?
Just wanted to check more on procedure. Um, Whether you want to basically do your talk and all questions after, or
It's up
clarification
to you.
questions
It's
along the way, or
Do
okay. Well,
you
the
have a specific procedure here?
in the sense that we're a working group for the Ostrom workshop, the typical pattern is to allow clarification questions. What do you mean by X? But save the things that are actually comments and discussion and such for
Yeah, I
afterwards.
don't mind. If you, yes, but it's up to you. I don't mind if you have any questions for clarification. But in terms of the timing, I will look at you, Maddie, to chair the session. So
Sure.
um, I'm open to any question if you have
If
any.
you if there is any kinds of clarification questions, please feel free to ask. Otherwise, we will have a discussion session after Ehsan's presentation, and we would be very happy to have your questions at that time.
Okay. So is there anything, or otherwise I can continue? Wonderful. So I'll walk you through the case study later on. So to get us started, I want to explain that what I mean by these computational technologies and why they are important. So there are three features that I feel like they're very important related to these technologies, like models, simulations. First, they are everywhere. They're quite ubiquitous. You can find them everywhere, from very rich data basins to ungauged basins. So they are everywhere, especially with the development of AI models. People talking about that, we can use models everywhere, literally everywhere. And again, with the new advancement in large language models, I would imagine the reach of these models even expand beyond what we have right now. So I just give you here a couple of examples that these are kind of proof of concepts, how people try to play with the idea of the large language models for water governance. For example, become advisor for policymakers, or chatting with a farmer, chatting with this chatbot to think about what sort of crops want to grow, or what sort of plants they want to have, and how they want to manage their water, right? So they are everywhere. So that's the very first thing that I want to emphasize. Second, they are perceived mostly as neutral technologies, or at least kind of neutral representation of truth or reality of the basin. So what they produce actually are perceived as objective evidence in relation to a basin. And they are very quite useful, at least helpful for people who are dealing with the conflict in a region. So they can play that role that, I can help you with deciding who is right or wrong. And the third one, which is actually coming from the previous point, is that they're extremely powerful in a way that they shape our sensibilities about the basin. So, for example, in terms of the surface water, groundwater, health of the basin, quality-wise, quantity-wise, but also they influence the decisions about the policies, regulations, what is needed, what is feasible, what is desirable. So they are not just describing what's happening in a basin, but they make a reality by constraining our choices. So they do things. So in sociology of science, people talk about the performativity of models. So they do things. They're not just sitting passively outside the basin. So all these factors, at least, are important to consider because it helps us to reject the idea that science and society are not necessarily related, but also to borrow from Shilja Jasanoff, they could produce one another in a complex way. And that is very essential in terms of thinking about how model and society and how model and politics are interacting in the context of a river basin. So to situate my argument, I thought that maybe I would just go back to a piece Catherine Daniel and I wrote almost 10 years ago. The other day I was just counting the years, and I said, look, it's 10 years ago. And what we were actually arguing was that we need more expansionist view of socio-ecological system, and the idea about the action and action situation that allows us to consider the role of non-human agents in the dynamics that happens in a river basin. So this is important, and this matters because it allows us to recognize the performative aspect of things like models, because they have this exceptional authority in our modern world. They shape our actions and behavior, but also our understanding of what is the state of our life is. And in a river basin, I would say this happens actually in three ways. First is that these models construct the very notion of water. So they participate in answering any sort of questions in relation to water. So if you have a model, it helps you to understand, for example, how much water do you have? Are you in crisis or not? So these are very important questions for the governance of in a river basin, right? So do we have enough, for example, environmental flow going to this fragile ecosystem, or cultural flow? So you can name all these questions, and this model allows us to have this authoritative answer to these questions. Second, they shape and constrain our choices, and they make certain options feels these are common sense solutions, or these are common sense to me, or some of these things are actually aligned with our common good in this basin. So and through that, it makes certain things desirable, common sense, but others nonsense. So this is coming from the power these models have. And the third here, which I feel like is very important, is they are durable. Long after the modeling is finished, the modeler is gone, the model stay in the basin and it still remains in the basin. It still shape the policy, it still be in the documents. If they are successful, they embed themselves in everything. They are in the in shaping the public narrative in a basin. So they're quite powerful even in the years after they finished in terms of a project that they are funded by. So what I was so let me so this is something very important for me to start with, that this models has this actorhood character that we need to start recognizing. But I'm thinking that, if this is correct, and if these models help people to see, conceptualize, relate to water in certain ways, they can play a significant role in how people relate to water, how they feel like this is their river, their water, and this is very related to way that is there any cultural imaginary about the river that these models are going to tap into, how people think about the water, if it is like, it is their rightful share of water, is it what they get, is it fair or unfair? And when I look at the literature, who gets there, they have a very amazing paper that they talk about the river commoning as a collective placemaking and community making process to make different dimension of rivers as a common good for enjoyment and the use of common. So I really like this definition of what is this river commoning process entails, as this social practice that you make certain aspect of the river in a way that you can see it as a common good for the use of that common. And if we accept this definition, then we can think about very easily that models can play a very significant role in this river commoning, because they have power in shaping perception, right? So they have power in shaping collective actions, thus they can play a role in the process of river commoning. And I would suggest here is that this process of river commoning is constructed in 3 sites, conceptual sites. The first is common resource. What is this common resource? The second is, what is this common sense here? And the third is common good. And these models intervene in these sites simultaneously. So they construct what is this we are dealing with at the physical level, but also at the cultural level and the social level. What does make sense to people? And also at more abstract level, what is this common good that we are striving for? So going through them one by one, maybe quickly, I would define this as the common resource. Model traditionally uses, or models actually are used to talk about what is this common resource actually is. And it helps us with the materiality of the water actually. So what is this physical state of the river? And how much do we have of that river that we can use? Or how does this circulation of water underground happening actually? Are we using the water efficiently or not? Are we in the crisis or not? Do we have extra water to transfer somewhere else or not? So these are actually constructing the notion of commonness in in a basin. The common sense models shape the common sense in a way that what this reasoning about the water and the resources people have feels like in the public and policy circles. When things becomes a common sense, it becomes common sense, and and the consequence is important because it naturalizes certain actions and certain solution and makes others kind of nonsense. And the common good is important here. The role that models play here is that in defining what basin ought to be and for whom. So, and the model is actually plays a significant role because based on what the model is optimized for, we can get a particular version of the basin to make decision or make sense of it. And I try to explain all these three sites in the case of Zayanderud very briefly. So to just give you a bit of context and background about the Zayanderud. The Zayanderud is in central Iran. And it crosses this beautiful city of Isfahan. And I'm in love with the city, and I did my master's degree there. So I just love the city. It's beautiful, culturally significant for all Iranians. And this is actually the largest river that in the central Iran. So, and this is a very arid region, right? So consider that in thinking about the region. And over the last couple of years, the river unfortunately doesn't reach the city and doesn't snake through the bridges anymore. So as you can imagine, it's devastating for the people who live in the city. It is it's an environmental significant consequence for the region. And it happens for a couple of reasons. So this is not a talk for talking about what happens there, but often people talk about multiple factors like over abstraction of surface water, groundwater, increasing agriculture in upstream. They have intensive industrial expansion, water intensive industrial expansion. And plus two major droughts that they have had over the last 2 decades. So put them all together, we have this dried river, which has lost actually half of its inflow of water. So we are talking about roughly 1 million cubic meter of water annually lost. And you can just imagine the socioeconomic and environmental consequence of this, just so devastating for the people. And thinking about, just think about the Cairo without Nile, thinking about London without Thames. And the feeling of that show you that, this is what is this in terms of the iconic loss for the city and the region. And this dried riverbed has become the space for public protest, and people get there, gather, demanding the government to give them back the river if they can. And the consequence at the tail of the river also is catastrophe, I would say. Environmentally, this is the Gulf Kuni wetland, which is under Ramsar Convention, but also 400,000 farmers who are deeply relied on this region. For generations, they did agriculture there. And I went there for doing my field work. People it's just so sad to just observe what's happened to the people who relied on this river for many, many generations. So put them together, I would say Isfahan and the region is on the verge of ecological economic collapse. The solution. Isfahan authorities, they propose Beheshtabad project as a water transfer project, 1.1 million cubic meter transfer to the Zayanderud, and hopefully it will solve the problem. And this is, as you see, this is the river from. This is not Zion Route. This is Karun, which I show here in on the map. But there are the sources that they want to transfer water from. Are the same sources for the Karun, which is the largest river in Iran. And as you see, this river goes from from very near the Chamal Bakhtiyari province, which is very close to Isfahan, to south of Iran, ends in Persian Gulf. And in order to give you a sense of this interbasin water transfer project, if it gets completed, it becomes the largest, biggest water transfer in the entire Middle East. So that's a scale of the project we are talking about. And this project has a scientific backing, for sure. 12 years of scientific study, feasibility study. So the science and the modeling actually seems legit, I would say. I just picked a few quotes here for you to see how the science works here. As the project lead says about the scientific rationale of the project, he said, quote, Beheshtabad, which is this water transfer project, has been studied and designed with the participation of reputable consultant with international experience from friends and prominent domestic consultant in accordance with technical standards. The study result underwent rigorous scrutiny in provincial committees and Iran's Ministry of Energy and were further reassessed by Austrian company, confirming the findings of initial approved studies, end quote. So simply you see, there's multiple stages of confirming this is a legit project. So this is scientifically okay project. And by leaning so heavily on modeling and hydrological and economic calculation, they created this narrative where opposing the project meant you were just not against the project, you are against science. Or you are against the rationale of scientific reasoning. And this is very interesting. I can talk about it a little bit in the Q&A, how it was difficult to fight against or actually argue against this project because it was already being portrayed as this is the scientific rationale of this project that is already being vetted by too many legitimate sources. And there was in the downstream Isfahan also there is this idea that if the water transfer project is cancelled or challenged, it will mean that 12 years of scientific study would go to the waste, and no one wants that for sure. But also there is another element here, that the sense of inevitability. So the situation is dire. We have the science, we have the water, which is extra water waiting to be diverted. Why not doing it? So that's why we have this paper. You can see in the title of the paper, Water Transfer to the Zion Basin, a choice or an indispensable necessity. And these are coming from very credible hydrologists who do their job very well in terms of what they think about what's the situation and what could be the potential option or exit option from this crisis that this fund is dealing with. So it is a kind of inevitable choice. But what I would want to emphasize here is that you might ask why everyone in the downstream, everyone just so happy or at least accepting this mega project water transfer to Isfahan. So everyone. So when I'm saying everyone, means everyone. Lay people, policymaker, water expert. And what I found is that it seems very interesting that ever since 17th century, I'm not talking about last 50 years, 17th century, there has been this prevailing vision of diverting water from the upstream to sustain Isfahan's development. And I found it in many travel notes from especially French travelers like Jean-Baptiste Tavernier, Chardin, and so many other people who traveled to Isfahan on their way to India, that they observed that, the king who was also overseeing the water distribution in the city and the capital, which was Isfahan back in the day, they wanted to bring the water for many times. And as you see here, this is the travel record that I found in the Tavernier's diary. So the quote, "Design of the river is of enormous help to Isfahan. There is another river in the south of Jolfa. There is called Karun. Shah Abbas I, who was the king at the time, attempted to connect these two rivers by blasting through the rocks between them. He failed. And in a couple of other records, he failed miserably because he tried a few times. It didn't work. And Tavernier, he talks about for this work, they needed the expertise of some of our European master engineers. If successful, the Isfahan plain could have gained immense benefit, becoming one of the most fertile and pleasant lands on Earth." So just set aside the European master engineers aside, but I feel like this is a very interesting thing about we are dealing with this centuries long kind of sense that in the region, if we want to make this region sustainable economically or maybe ecologically, there is a need for diversion of upstream resources. And finally, this imaginary finally realized by the investment from the farmers at the tail of the river. So I show you those 400,000 people and the local and the national government. They put money together and they built this project finally in 1950s and became the first actually Kuhrang tunnel that which soon celebrated as a symbol of Iran's modernization, and it became at the back of the banknote in Iran. So it became something as a masterpiece of engineering, I would say, but it also expanded very quickly. So we have a trilogy of Kuhrang tunnels. Since then, Kuhrang 1, 2, 3, and they want to expand what they can bring from the upstream to downstream. But going back to the current crisis and what modeling and calculation justified for the Beheshtawat tunnel, I think that it's interesting to look at what are the assumptions in their calculations. And that's part of, I want to a little bit talk about that. Few items here are interesting because they are actually arguing that there is extra water in the upstream waiting for us to be diverted. And in the calculation, there are a couple of assumptions here that needs to be discussed, at least. And for example, they look at what the river of Karun, the whole river, and that natural inflow, because it ends into the Persian Gulf, they see this as a wastewater in principle, which is interesting. But there are so many other things that they focus on in the models and the calculation, which is one of them that they focus solely on Isfahan needs and deficit. And what the region of Isfahan, which means downstream, they needed for their ecosystem to survive and grow. And they didn't necessarily focus on the upstream and their ecological and social needs. And for example, for the upstream ecological needs, they assumed that if there is something happen, their local springs which they have would somehow cover the environmental flow for the Karun. So there were kind of very interesting assumptions that was made. But also there was another thing that they did was that they didn't necessarily engage with the history of failure of the past transfer project in the region, because as I said, they had a trilogy of water transfer, and the reason for that was that each time they had the water transfer, the consumption catch up with the supply. So anytime you have more water, more consumption. So I'm happy to show you more graphs in the Q&A. So what has happened in the region. So even that discussion was erased from the modeling and calculation as well. What happens, as you can imagine, those people in the upstream, they're not happy with the proposal, and they saw all the science and the calculation as just this justification machinery to justify the decision that is already been made. Let's put it that way. And they would say, oh, we have got our own problems of water. We don't have water. We are sitting in the upstream. We don't have water. We have been historically economically disadvantaged compared to downstream. So if there is any water, we want it first. And even in the downstream of Karun, there is another group of people. They were not happy either. They said, plus all those concerns, if there is a lack of water coming to the Karun, because you want to divert it to Zion the route, there will be a risk of seawater encroachment from Persian Gulf to the farmland in near their area, and that will create a cascade of environmental problems for us. And as you can imagine, the whole region were not happy. They organized a street protest, forming human chains for kilometers. And they see this water transfer a kind of curse, right? A symbol of death for the region. And as a result of this, in 2013, 18 members of the parliament in Iran from these regions, they collectively resigned from parliament. So you can imagine the scale and the political and the security aspect of this water problem. But what I found very interesting too is how, when you talk to these people, how they talk about the proposal of the water transfer as a nonsense. So that in the interviews, they try to make sense of the situation, but they couldn't. So this quote is coming from the member of parliament in the downstream in the Karun, which is a donor river. And they said, quote, should we leave one province thirsty just to satisfy another? What kind of common sense is that? The water shortage, drinking water problem in towns and villages, and thousands of water environmental issues in our province all come from transferring Karun water, previous transfers, right? Is that really for the common good? End quote. So you can see that, they're struggling to understand, so what is this common good here? What is this common sense here? So what happened was that as a result of this unhappiness, if you like, modelers, they said, okay, in the upstream, they said, let's do something. So they produced their own counter models to the Esfahani's calculation. And they try to actually resist that narrative of water transfer to what, actually, this is what they told me. They put it in that way, to defend the Karun, so to defend the other river. So the modelers taking this activist, perhaps, role in order to defend the other river. So what they did, they introduced different modeling structure. They look at the same, actually, system. We are talking about the same system, right? Different modeling structure, variables, boundary judgment, and data. So they didn't use the data that Isfahan's, for example, use. They have their own data. And what the purpose here was that to highlight and pronounce this negative consequence of water transfer for themselves. So that means that the water has to serve another set of community for different set of common good here. So they included, for example, all the water project, population growth, or long-term ecological health of the river, all things that were missed in the previous calculation. And what they found was that there is not actually that much of water available. There is no surplus here to be diverted. So there is a little bit here and there. So it's just half of that water just disappeared. So in a way, that model was used to push certain narrative. But what happens to that water is we're not dealing with this pre-existing H2O that we are dealing in the governance of the basin. We're dealing with something that is quite plastic in a way that, based on the logic of model, you can have a different way of thinking about the water and the river and the actions that you can take here. And finally, actually, they were quite successful in terms of by circulating and the result of their models to different science and policy circles, they could delegitimize the initial plan and stop the project as it was planned. So maybe I would just quickly show you side by side how this common sense, common resource, and common good are different on both sides of this equation. And then the last slide. So these two slides, I just simply want to say both sides, they are dealing, first, I want to emphasize, both sides, downstream and upstream, they are dealing with something very serious. And both modeling and studies, at least as far as I am aware of those things, they were technically correct. The difference, though, here is that what the reality of each model representing, and whose future it was optimized for through that modeling process. So the model helped to elevate certain aspect of the basin over the others. So, for example, in the downstream in Isfahan, water and the common resource is become this. Zayanderud is our river. We has historical right to it, and if there is anything upstream as a surplus, we should have a say in it, right? So because we have historically been the manager of the river, and they thought about the water as a kind of national commodity, which was very interesting to me in my interview. What I found was that it can be moved to maximize social and environmental value. So, which is very different from the upstream, which was a kind of local understanding of water, which is more about making sure that this region is going to survive because the whole ecosystem is fragile. The common sense in Isfahan was that water has historically flowed from those upstream sources, so tapping to them makes sense. Science backs our ideas and proposal. It's not political. It is rational. It is evidence-based. It does make sense. And the situation is dire, so the stakes are high and real. Farmers, wetland, I show you all these things. So we are dealing with something genuinely urgent here. And the water's transfer actually makes sense. And the common good is making sure that Zayanderud survives and we survive, and the security of Isfahan and economic growth of Isfahan and the social stability of Isfahan is the first priority. And Isfahan's good is the region's good, and the region's good is Iran's good. So this is that kind of narrative is also very important in this construction of what is this common good we are dealing here. On the other side, for the upstream, Charmahal, water is a kind of local ecological lifeline belonging to the communities that it flows through. So they see this, if there is any water available, we have to use it first. It belongs to us. We have to serve our own communities, our own ecology, our own future first. And also these upstream resources, if there is any, it belongs to another river, which is Karun. So it's not just belongs to Zayanderud. In terms of the common sense, they would say transfer might be sustainable solution to downstream. It doesn't make sense to us because it's just because of the history we have here. So there is a historical context that create that common sense that this doesn't make sense to us. And the real crisis for them here is that there's no problem with water shortage. If there is a problem, there is the downstream problem of poor water management. So again, there is another different way of thinking. And their common good here is we have to protect the Karun. And the river is already burdened by previous past, but we have to take care of that. And this is the last slide. What I want to do again emphasize here is that models are not passive tools. They are participant in river commoning here. And as I said, if we are talking about water, we are not dealing with something very quite physical in a sense of H2O. But it's something that, it depends on how models represent that reality to us. And if there is any counter modeling, it is also part of the commoning. So this modeling is part of the commoning, counter modeling is part of the commoning. So it creates this bonding process in the basin. And based on that, we need to rethink about the notion of action situation in order to include all these computational actors as the active participant in basin dynamics. And this means that we shouldn't take for granted what is this common sense, what is this common resource, and what is common good here. And we need analytical tools or ways of thinking in order to help us to see how these are made, unmade, contested, challenged, and remade and renegotiated, and what's the role of models here. Maybe I will stop here, but this is the paper that, if you are interested in the full story of Zayan Darood, you can find more information in it. Thank you.